There's one main thing you guys need to remember when it comes to systems of equations. And that's basically that systems, all it ever really asks for, and the main point of them is the intersection of functions. So when you look at systems, when I say system, we're talking about basically just more than one function on a graph. And when I say solutions to a system, I'm looking for where those functions are intersecting, where those functions overlap or they cross. We're not talking about where they cross the x-axis or the y-axis or those sorts of things. We're not interested in like this point here where it crosses the x-axis or there or there or the y-intercepts. We don't care about those points. What we're interested in the solutions to systems is where the two functions cross. Now, in number one, the functions look kind of silly, right? I mean, you got this oval-shaped function here, but that's still considered one of our, well, it's not really a function, but we'll skip on that for now. But that's one of our equations, if you will. And then the other one is this line here. So that's a system because a system is just having more than one on a graph. And then a solution to a system is where those are overlapping, where those are intersecting. And those are clearly intersecting, here and here. So let me erase this so we can kind of read it a little bit better. But that intersection, it looks like we have one here at the point 1, 2. So that's x1 and y2. And then we have another point there, which looks like about 2, -2, where x is +2, y is -2. And so that's our answer. It's just, which portion of the graph, blah, blah, blah. Most likely the solution set for the system. So the solution is where those two lines or functions, whatever you want to call them, are crossing each other, and they cross twice, and that would be those points. All right, so let's move on to number 2. Number 2 is basically the same thing. What is most likely the number of solutions for the system of equation? Now let's read the question carefully. What is most likely the number of solutions? It's not asking us for what are these solutions. It's just how many solutions are there. And again, so solutions are where the two functions intersect. So I have one function here in this parabola, and I've got another function here in this line. And so how many times do they intersect is what the question's asking for, and I believe you can answer that, right? That's just, it clearly only intersect in one specific spot. So 1 point of intersection, 1 solution. Number 3, which is the apparent solution set to the system of equations? So again, it's asking for the answer or what, not how many there are like the last question. It's asking for the solutions. Where do they intersect? Where do these two functions intersect? And it's sort of a trick question, but not really. I mean, you have one function here in this parabola shape, and you've got the other one, of course, in this line. And the answer is where they intersect. And I'm not trying to fool you. You can tell that they don't intersect. They don't touch each other. They don't cross. So because of that, there's no solution to that system. So number 4, what is the solution to the system of equations? So it's asking basically when it says what is the solution, it wants to know where they cross. So again, it's pretty, this one's a little more something you've been used to, seen over the years. You have one function there, that line, and you have another one here, which is that line. Solution is where those two lines cross. They're clearly crossing right about there, which is -1, 2, I believe. So these first few go pretty quickly because they have the graphs and everything of that nature is provided. But now let's get into some stuff where we might want to use a calculator or something along those lines. So I'm going to do these. I don't know how I'm going to do this yet, but there's some that I'm going to use the calculator strictly for, and some that I might use the calculator and just hand done work. We'll see. We'll see what I do. But anyway, Number 5 is one that we're going to do by hand because it would be easiest that way. But let's understand the question first. So Kiko determined that the coordinate points -4, 0, -3, -1, 2, -6 are solutions to the following system. Which coordinates from the solution set are reasonable solutions to the system of equations? So one thing, again, that you need to know, we know that, apologize. We know that solutions are where the graphs cross, and you certainly could graph this and see where they cross, and we probably will do that. I'll probably do that in a separate video. But in this video, I'll show you a real quick way you can just check, because it's already answered for you, sort of. It's this person decides that the solutions are these points, and to see if he's right, that would have to mean that each ordered pair can fit into both equations as true. So what I'm going to do is I'm just going to take one ordered pair at a time, plug in its x and y into both equations, and see if it's true or not. So we have the equation y equals -x minus 4, and we have the other equation y equals x squared plus x minus 12. And one of the points in question, the first one we'll talk about, is the point -4, 0. Does this fit in the system? Well, if it does, then we can plug this x and this y in to both equations and it'd be true. So let's plug it in the first equation. If we plug it in the first equation, we'll have y. Oh, I'm sorry, we got to plug it in for y. Y is 0, so I'm going to plug in 0. So 0 for my y equals negative. So that negative's still there. And then I'm going to plug in x, which is -4. And then minus 4. So let's see if this works. So -4 means that this will become a +4. So I have 0 equals +4 minus 4. And 4 minus 4 is indeed 0. So as far as the first equation goes, that point, that x and y, fits in that first equation. So now let's see if it fits in the second equation. So y equals, but again, I'm using 0 for y here because that's what it says in the equation, or the point that I'm looking at. So equals x squared. So I'm going to plug in -4 for x squared plus, again, x. So I'm going to plug in -4. And then plus 12 or minus 12. So let's see if it works. So 0 equals -4 to the second power. -4 times -4 is a +16. Now, if I'm adding a -4 like I am here, adding a -4 just means the same thing as -4, and then I've got minus 12. So 16 minus 4 is 12, and then 12 minus 12 is 0. So that works as well. So that is a solution, -4, 0. -4, 0 is a solution. So keep that in mind. That works. Now let's try one of the other points. We've got 3 to check, so let's pick the next one and give it a try. So the next point in question is -3, -1. -3, -1. That x and that y. So we'll do the same thing, plug in the x and y and see if it works. Now I'm not going to bother changing colors because I feel like that's going to just take too much time. But you get the idea. So let's try it in the first equation here. So y is -1, so we'll use -1 equals to -x. So that's -3 minus 4. So -1 equals, now -3 makes a +3, and then minus 4. And 3 minus 4 is -1. So that first equation checks out. So now let's plug it in to the second equation. So the second equation is y equals, so we're going to say -1 equals x squared, so it's going to be -3 squared plus x, which is -3, and then minus 12. So this says -1 equals, -3 squared is a +9. This becomes -3, and this becomes minus 12. So 9 minus 3 is 6, and 6 minus 12 is -6. So -1 equals -6 is what this says. Now that's not true. -1 does not equal -6, so it does not fit in this equation. So this point is not a solution to the system. So Kiko was wrong about that one. But we still need to check the other one to see if the other one works, or if it's just the -4, 0 point that works. So the last equation we're going to try, or the last point we're going to try, is 2, -6, because that's given to us in the problem. So x, y, plug them in. So y, we're going to plug in the first equation first. So y is -6 equals -2 minus 4. So this says -6 equals, now -2 is simply -2. No double negative there, like the last few times where it canceled out, but that's going to be -2 minus 4. -2 minus 4 is -6, so -6 equals -6. That's true, so it works in the first equation. Now let's see one more time just to see if it fits in the last equation. So the last equation, this one here, y is -6, so we're going to plug in -6 equals 2 squared plus 2 minus 12. So we're plugging 2 for x and -6 for y. So this means -6 equals 2 squared is 4 plus 2 and then minus 12. So 4 plus 2 is 6. And then 6 minus 12 is -6. So -6 does equal -6, so that's true. So this point and the first one both work. So to answer our question, it would be option 2, right? 2, -6 works, and -4, 0 works. Just -3, -1 does not. All right, number 6, I'm gonna go ahead and do straight in the calculator, but I'll do that in the second video. So just jump over there and check that out, because that one is just going to be much easier to do with a calculator. Number 7 is the same thing. I'll do that in the calculator. Number 8, 8 and 9, I guess we'll both do in the calculator. So as far as the non-calculator stuff goes, that'll be it for this. I'll just do a few of those in a separate video, just so this one's not too long. All right, I'll see you guys then. Bye.